What if the next generation of giant space structures could literally snap themselves into shape on orbit with almost no power? Researchers at Cornell may have just cracked the code. Building massive structures in space is one of the great unsolved challenges of our time. We need kilometer-scale reflectors for climate monitoring, solar power collection, and disaster response. But today's in-space manufacturing approaches require enormous power, move painfully slowly, and produce structures that are too heavy to control. Even the largest rockets can't launch a folded reflector beyond 100 meters in diameter. We need a fundamentally different approach. Lalisani and Royer propose an elegant solution, a cellular metastructure made of bistable unit cells. Each cell is a pair of thin composite arches, one on top, one on bottom. When you push down on the top arch, it snaps through to a second stable shape. The key insight is that the bottom arch acts as a built-in spring, providing just enough confining stiffness to lock the cell into its new position, with no external supports needed. By selectively snapping individual cells in a long deployable boom, you can program the entire structure to curve into any desired shape. A parabolic reflector, an S-curve, even a full semicircle. All with minimal force, using nothing more than elastic buckling of ultra-thin composites. The team's finite element simulations reveal precise design rules. Bistability kicks in when the bottom layer is at least 3 times thicker than the top. But with a hybrid carbon glass composite, that threshold drops to just twice as thick, opening the door to lighter structures. A critical region of influence exists around each pinched cell. Space them at least 2 cells apart, and they behave completely independently. The curvature is fully programmable. Close pinching gives tight curves. Distant pinching gives gentle bends. By alternating the pinch direction, the team even produced S-shaped booms. And remarkably, adding length to the structure doesn't change the bistability threshold at all. It scales beautifully. This is a proof of concept that could reshape how we build in space. A single deployable boom coiled for launch could be programmed on orbit to become a parabolic antenna, a solar reflector, or a structural member. All from the same hardware. The team is now experimentally validating the concept by shaping a 1-meter boom into a circular arch. Snap-through morphogenesis, programmable shape, minimal power, and a new path to building the largest structures humanity has ever put in space.